quantum computing poses opportunities and threats both to the fields of cybersecurity. Here's the background how quantum computing impacts field of cybersecurity. Let's discuss quantum computing and its capabilities in a nutshell. Quantum computing leverages the principles of quantum mechanics such as quantum parallelism, quantum superposition, quantum entanglement to perform difficult and very complex tasks at unprecedented speed. The comprising element of quantum computing is qubit, quantum bit. Unlike classical computing that's comprising of the classical bits 0 and 1, quantum computers are comprising of the quantum bits. Qubits may reside in quantum state 0, quantum state 1 and superposition of quantum state 0 and 1 simultaneously. Apart from opportunities, quantum computing poses threats to cybersecurity. Let's try to understand three major points in which quantum computing poses threats to cybersecurity. Number 1, quantum computing can break the classical encryption techniques. The current classical encryption techniques like DSA, digital signature algorithm, ECC, elliptic curve cryptography, RSA, Rivest-Shamir-Adleman, classical encryption techniques rely on the difficulty of factoring large numbers or solving discrete logarithmic problems. The Shor's algorithm that was developed in 1994 can solve these problems quite easily at unprecedented exponential speed, rendering the classical encryption techniques such as RSA, DSA, ECC obsolete. Impacts of quantum computing on PKI, public key infrastructures. Digital certificates, secure communication protocols such as TLS or SSL, blockchain security depend on classical techniques. Once quantum computers reach the sufficient scale, those can break these systems. Another example where quantum computing is threat to cybersecurity is the brute force attacks on passwords. Grover's search algorithm can speed up brute force attacks significantly by reducing the search time from the order n to the order square root of n. These are the main three examples in which quantum computing poses threats to cybersecurity. These three cryptographic algorithms such as DSA or digital signature algorithm, ECC, elliptic curve cryptography and RSA, Rivest-Shamir-Adleman are three cryptographic algorithms that are widely used in today. Let's compare these three cryptographic algorithms, mechanisms, security and use cases. The three cryptographic algorithms DSA or digital signature algorithm, ECC, elliptic curve cryptography and RSA, Rivest-Shamir-Adleman encryption techniques are widely used in today's world. Although quantum computers can break these systems by using Shor's algorithm that was developed in 1994, let's explain and compare these three cryptographic algorithms or classical encryption techniques in detail. The RSA classical encryption technique is basically the abbreviation of Rivest-Shamir-Adleman encryption technique. It is widely used to secure communications. The type of RSA or Rivest-Shamir-Adleman classical encryption techniques or cryptographic algorithm is asymmetric or public key encryption. Let's talk about security basis of RSA or Rivest-Shamir-Adleman encryption technique. The RSA encryption technique is used to secure communications. The key size of RSA or Rivest-Shamir-Adleman encryption technique. It works well in 2048 bit or higher systems. Let's try to understand how this RSA or Rivest-Shamir-Adleman encryption technique works. The working procedure of RSA or Rivest-Shamir-Adleman encryption technique is based on three steps. The first step is key generation, then encryption, and the final stage is decryption. The strength of this RSA encryption technique is it's widely used to secure communication protocols such as TLS, SSL, PGP, and digital signatures. It's also very much useful to factorize large prime numbers. Apart from strengths, the RSA cryptographic algorithm or encryption technique has a couple of weaknesses as well. The first weakness is vulnerable to quantum attacks. RSA encryption technique is way slower than the another encryption technique called ECC or elliptic curve cryptography. ECC or elliptic curve cryptography encryption technique, let's try to understand. The ECC encryption technique or elliptic curve cryptography technique is an asymmetric public key encryption. Our 256-bit ECC key is equivalent to 3072-bit RSA key, and the ECC encryption technique uses the ECDLP or elliptic curve discrete logarithmic problems. Let's try to understand how this ECC or elliptic curve cryptography encryption technique works. The classical encryption technique ECC or elliptic curve cryptography is way faster than the RSA or Rivest-Shamir-Adleman encryption technique. The work procedure of this ECC or elliptic curve cryptography technique is based on three steps. The first one is key generation, the second one is encryption, and the final one is decryption. Let's talk about the strengths of this ECC or elliptic curve cryptography classical encryption technique. ECC is way faster than RSA or Rivest-Shamir-Adleman encryption technique. It is very much useful with low key size. Let's talk about some weaknesses of this ECC or elliptic curve cryptography encryption technique. ECC or elliptic curve cryptography encryption technique has a couple of weaknesses as well. The first one is the implementation flaws can lead to vulnerabilities, and the second one is ECC has more complex mathematical operations than RSA encryption technique. There's another one encryption technique which is the digital signature algorithm or DSA. Let's talk about its size, security basis, and type. DSA or digital signature algorithm is of asymmetric type. It's basically a digital signature but not encryption. Let's try to understand the security basis of this DSA algorithm. It works on the digital logarithmic problems. The key size of DSA is 2048 bit for security. A minimum of 2048 bit is required for security in this algorithm. The working procedure of DSA or digital signature algorithm is based on three steps, that are key generation, signature generation, and signature. There are a couple of strengths of this DSA or digital signature algorithm, which are firstly very much secured when implemented properly, and the second one is useful in digital signature and authentication. There are a couple of weaknesses of this DSA algorithm as well. There are a couple of weaknesses of DSA or digital signature algorithm that are: this is not used for encryption, it is used for signatures only, and the second one is it requires random number generation for each signature. So these are three classical encryption techniques: ECC or elliptic curve cryptography, DSA or digital signature algorithm, and RSA or Rivest-Shamir-Adleman encryption techniques. Quantum computing can break these classical encryption techniques very easily at unprecedented speed. This is the threat of quantum computing for cybersecurity.